All right. Hello, everybody. This is Miss Pie. My allergies are killing me still, so I'm taking the day off. I recorded this video to help you with the Sum and Difference Identities worksheet that you are going to be working on today. Before we get started, please make sure you have a calculator handy, your green sheet that has all the trig identities on it. You also need your, let's see, what else do you need? Green sheet. Oh, your exact value table, your trig table. Okay, one that's like over, hold on, let me write it, do an arrow. It's on my wall over there, right over here. Anyway, so let's go ahead and get started. We are first going to look at some problems up here that we are adding together, your sine functions, and if you notice, if we take this angle 90 and we want to add together two sine functions, that the angles together will equal 90. So in this example, we have sine of 90 degrees and then plus sine of 0 degrees. Well, if you take the angle 0 plus 90, that equals 90. And you'll notice with all of these problems, if you add up the two angles, here's 30 and 60, and those will add up to 90, 45, 45 equal 90, and again 90 and 0 equal 90. Okay, so now this is just a snapshot of the trig table with your value, well, part of your trig table. This only has 0, 30 degrees, 45, 60, and 90 degrees, and then only sine, cosine, or tangent up here. But you can find these values on your trig table. All right, so let's look at if we had sine of 90 degrees. Go down here, 90 degrees is here, sine column at 0. So sine of, not 0, sorry, 1. So sine of 90 degrees equals 1, right? So let's plug each of these trig functions in, or check their ratio in the trig table and see what we'll come up with. So we have sine of 90 is 1. Okay, so we know that sine of 90 is 1, but what is sine of 0 degrees? Go down to the trig table, we have 0 degrees. Sine, in the sine column, you have a 0. So if we add 1 plus 0, we get 1. So in this case, this statement or this equation is true. Okay, this works. Okay. If we look at another problem and we check the ratio for cosine of 90 degrees and compare it to the ratios of cosine of 90 degrees plus cosine of 0 degrees, do you think it will still work? Let's check it out. So here's 90 degrees, here's the cosine column. Cosine of 90 degrees equals 0. Okay. And then, so cosine of 90 degrees equals 0. What's cosine of 0 degrees? 0 degrees, cosine column is 1. So right there, we have a 0, and it does not equal 0 plus 1, which is 1, right? So I know this is very basic, very easy. Just stay with me for a little bit, put the phones away, and pay attention to this, and you'll see where we're going in just a second, okay? So in this case, up here, it worked. We had the equation is equal to each other. In this case, it did not work. 0 does not equal 0, or does not equal 1. Okay, let's look at problem number 3. You have sine of 30 degrees plus sine of 60 degrees equals sine of 90 degrees. So let's check that out. Sine of 30 degrees is 1/2. Sine of 60 degrees is square root of 3 over 2. Okay, so we have 1/2 plus square root of 3 over 2. And then sine of 90 degrees equals 1, or should equal 1. So if we plug that in and set up all our ratios, we notice that this equation is wrong. That does not, 1/2 plus square root of 3 over 2 does not equal 1/2. Or sorry, does not equal 1. Okay, and then the last example, tangent of 45 plus tangent of 45, does it equal tangent of 90? So here's the tangent column, 45 degrees. Tangent of 45 is 1. So let's go ahead and write that down. Tangent of 45 is 1 plus 1. Well, that should equal 2. But if you go down the tangent column to 90 degrees, notice it's undefined. Okay? So 2 does not equal undefined. So in this case, again, it is false. It does not work. Okay? So from this practice or this example, we know that we cannot just add the ratios together when we have a sum or when we have an angle like this. Sometimes it will work. In this case, it worked once, but most of the time it will not work. So we have to use our sum and difference identities. Okay. So why would we use this? Well, there's sometimes that you might have angles of, let's say you had the angle of 105 degrees and you wanted to know what cosine of 105 degrees is, but you wanted the exact answer. Okay? Well, notice if you add together 45 degrees plus 60 degrees, you get 105 degrees. So you can use your sum identity to find out what cosine of 105 degrees is. Okay, so let's look at our sum and difference identities. These are on your green sheet with all your trig identities on it. It's on the front. I believe it's at the very bottom. Notice we only have sum and difference identities for the sine function, the cosine function, and the tangent function. We don't have to worry about cotangent, secant, or cosecant. Okay. Again, I don't expect you to memorize these. These are super crazy equations. Just know where to find them, and we're going to practice using these today. Okay. The first thing we're going to do is actually prove that they work. Okay. This is the second page of the packet of green notes that you picked up a couple days ago. We went through the first page, I think, yesterday or the day before yesterday. And we're going through the second page today. Okay, so all this is it shows you how to prove that cosine of A plus B is going to equal cosine A times cosine B minus sine A times sine B. Okay, the way you're going to prove this is you're going to take all of your A's that's in the equation, every single one of them, and you're going to plug in pi over 3. Okay? Then you're going to take all your B's in the equation and you're going to plug in pi over 6. These are just two different special angles that we're plugging in. Okay? Now, I know usually when we prove identities, we do not work with both sides, and in a sense we're not going to multiply both sides by any number or anything like that. We're going to keep each side independent of each other. Okay? And so first we're going to figure out what this side equals, and then we're going to figure out what this side equals. So here, if you have just inside the parentheses, that's all we're going to look at for now. We have pi over 3 plus pi over 6. Well, you have to get a common denominator here, so this would become 2 pi over 6 plus pi over 6, which gives you 3 pi over 6, which reduces to pi over 2. Then we're going to look at our trig table. What is the ratio when cosine of pi over 2? Well, that's 0. Okay, so now I know that if I plug in pi over 3 for A and pi over 6 for B in this function, I should get the value of 0. Okay, so if you look, we just plugged our angles in. Then you go to the trig table, go down to pi over 3 in the radian column, go over to the cosine column, and you should have 1/2. For cosine of pi over 6, you should have square root of 3 over 2. And then sine of pi over 3 is square root of 3 over 2. And sine of pi over 6 is 1/2. Okay? Now when you're multiplying fractions, remember you multiply straight across. So 1 times square root of 3 is just square root of 3. And then 2 times 2 is 4. Square root of 3 times 1 is still square root of 3. And then 2 times 2 is still 4. So now does this side equal this side? Okay, and we can see that it clearly does. So when we're proving that these sum and difference identities work, that's all we're doing. You figure out what each side of the equation equals, and then you check and see if they're right. I will tell you they should equal each other. Most likely, if they don't, you probably messed up in the math up here somewhere. Okay? All right, so let's look at another example. This one is on your worksheet. You have the difference identity for cosine. So you have cosine A minus B, and then in this case, we're using the same angles for A and B, pi over 3 and pi over 6. Okay, so on the left side of the equation, we plug everything in. Let's see, I think I did something wrong there. No, I didn't. All right, so 2 pi over 6 minus pi over 6, yes, that gives you pi over 6. You look up in the trig table, go down to pi over 6 in the radian column, go over to the cosine column, and you get square root of 3 over 2. So this is what our final answer should be. Okay, when we plug everything in the right, that's what we should get. Let's see if it works. Okay, so we're plugging in pi over 3 for A, pi over 6 for B, and then notice, make sure you're using the correct formula. So if it's cosine A minus B, this is what the equation looks like here. Okay, now go through on your trig table, find these values. What is cosine of pi over 3? What is cosine pi over 6? So you should have 1/2, and then square root of 3 over 2 for cosine pi over 6. You're going to multiply those together, and then you're going to add that to sine pi over 3 and sine pi over 6, which you have square root of 3 over 2 and 1/2. Okay, when you add those together, you end up when you multiply these and add them together, you get square root of 3 over 4 plus square root of 3 over 4. It adds together to get 2 times square root of 3 over 4, and the 2 and the 4 reduce to the square root of 3 over 2. All right, I know I went through this fairly quickly. I will ask the sub to pause this for a little bit, give you guys a minute or two to catch up and see and verify that all my work is done correctly. You can also look here and compare that indeed these two answers are the same. So I've done this work correctly. All right, so Seb, go ahead and pause this for about a minute and then push play again. There's the bell. All right, now let's look at another problem. I am not going to do every problem in this packet with you guys, but I will do a few of them. All right, so now we're dealing with the sine function. It looks very similar to the cosine function, the cosine sum identity for cosine. Let's see, so we have sine A times cosine B plus cosine A times sine B. Again, we're using the same angles, pi over 3 and pi over 6. So if we plug our angles in and then add them together, we get sine of 3 pi over 6. That reduces to pi over 2. We look in the trig table and we should get a 1. I'm trying to remember if I did this one. Yep, I did. All right, so now plug everything in to the right side of the equation and plug your angles in, set up your formula. Please, guys, show your work. There's a lot there's a lot of work to do. Make sure you show your work. Okay. Now, this is how the formula is set up. You need to go to the trig table. What is sine pi over 3? What is cosine pi over 6? Plug all of that in, and you get this. Okay, multiply everything out. Square root of 3 times the square root of 3 is going to be 3. 2 times 2 is 4, and then 1 times 1 is 1, and 2 times 2 is 4 again. So you end up with 3/4 plus 1/4. You add them together, you get 4/4, which reduce to 1. Okay, so again, this side matches this side. Okay. Let me see. All right, so again, I feel so bad calling the sub a sub. I'm sure he or she has a name, but I have no idea who it is. So substitute, if you can, pause this again. Let my students take notes and work through this on their own, and then go ahead and start the video again. All right, here's your next problem. With this one, I set up the left side, so you know your final answer should be 1/2. I want you to do all the work on the right side of the equation. Okay, have fun with that. If there's time in class, go ahead and ask the sub to pause this. I'll let her pause this for 5 minutes before she moves on. Okay. If you guys are too disruptive, or if you have your cell phones out, she's going to just go ahead and keep playing the video. All right, so now go ahead and pause this, give the students time to work it out, and then we'll move on. All right, now for a tangent problem. If you notice, let's go all the way back here. Your sine and cosine sum and difference identities. The left side of the equation looks very similar. There's only very slight changes between which function goes where and whether you're adding or subtracting. Your tangent functions look very different. You've got fractions here, okay? So let's go through one of these tangent problems. Of all of the sum and difference identities, tangent is probably going to be the most difficult just because of the added fractions. But the process is still the same. First you plug your angles in for A and your B, and you check both sides of the equation, see what they equal. So we have, for A it's pi over 3, for B it's pi over 6. Get common denominators, do the subtraction, and for this one you would have tangent pi over 6, and you look at your trig table and you get the square root of 3 over 3. Alright, so now let's look at the other side. So plug in your angles. So you have pi over 3, pi over 6, and set up your formula, please. Take the time to write it down and set it up. And then go ahead and look in your trig table, see what ratios you can replace tangent pi over 3 and tangent pi over 6 with. Okay, and when you do that, you should get square root of 3 minus square root of 3 over 3 in both the numerator and the denominator. That looks scary, right? Okay, please do not use your calculators right now. If you plug it into the calculator, you might get the right answer, but most likely you'll put it in, you'll mess something up with all these fractions, okay? Let's try to simplify this. First, in the numerator, before you can do any subtraction, you have to have a common denominator. So you're going to multiply your square root of 3 by 3 over 3, okay? Now that you have common denominators, you can go ahead and do the subtraction. And then in your, down here, you have square root of 3 times the square root of 3, which gives you 3. I didn't do that yet. Hold on, let me see, where did I do that? There we go. So in the numerator, we end up with 3 times the square root of 3 over 3 minus square root of 3 over 3. So we just get square root of 2 times the square root of 3 over 3. And then in the denominator, you get 1 plus 3 over 3, which will end up being 2. Okay, so what ends up happening is you've got fractions and fractions. I went ahead and converted this to a fraction. Anytime you have that, you have to multiply by the reciprocal of your denominator. I know we've done that a million times. So you have, what happens here is you have your 2's end up canceling out, and you have square root of 3 times 1 is just the square root of 3, and you just have a 3 in the denominator. Okay, so I know that looked totally crazy. It is totally crazy. You just need to remember, anytime you have to add or subtract fractions, you have to get a common denominator here, and then please keep the calculators off for now. We will use them later on, but for now, just keep them off. All right, so substitute, go ahead and pause this, give the students a minute or two to get this stuff down, and then push play again. All right, here's another problem. Again, I've shown you how to set up the left side, and I'll let you plug everything into the right. You notice here when we did all this math, we have tangent of pi over 2, which is undefined. So this part, when you plug everything in, for some reason you're going to get the term undefined. And because I have a fraction, I'm willing to bet you're going to end up, somehow you will end up with a 0 in the denominator. And we know that anytime 0 is in the denominator, it's going to be undefined. So plug everything in, do all your adding, subtracting, multiplying, and dividing, and see if it works. All right, so now if there's time, go ahead and pause it for about 5 minutes, give the students time to work on this, and then we'll move on. All right, we are going to go ahead and look at a different part. What we've done so far is just proving that the trig identities work. Now we're going to actually apply them, or I'll show you how you can use these sum and difference identities to find the exact values for angles that are not on your trig table. Okay, so first of all, we have our special angles on our trig table are 30 degrees, 45 degrees, and 60 degrees. Okay, but what if I had the angle 75 degrees or 105 degrees or 15 degrees? Okay, I know that for some of these, there's only one combination that you can use. Notice we have 15 degrees twice. The reason why is because there's two different ways we can find that. Okay, so if we wanted to come up with 75, what two angles could we add together? Well, 30 plus 45 equals 75, right? If we wanted to come up with 105, 60 plus 45 equals 105. And then if we want to come up with 15, there's two ways to do it. You can take 60 subtracted by 45 degrees and you'll get 15, or you can take 45 minus 30 and you'll get 15. So these are the combinations, or the adding and subtracting of your special angles, that will allow you to get 75 degrees, 105 degrees, or 15 degrees. Okay, let's go ahead and use this. Before we get started, turn on your calculators. This is a time where we will be using the calculators a little bit. And because we are working with degrees now, everybody needs to put their calculator in degree mode. You know how to do it. We've done this a million times. Excuse me, get to the home screen, go to settings, right here. Whoops, I'm so lame. My mouse is not working. There we go. So get to the settings part, then go to document settings. The second thing is your degree or radian. Make sure it says degree here. And then you need to come down and click on default. When you click on make default, it'll ask you if you are sure, push enter, and it'll do it. All right, so now actually applying this, we want to come up with we want to know what cosine 105 degrees is, but we want the exact answer. And so we're going to use 60 degrees plus 45 degrees. And so when I plug that in, let me move some of this. Let's see. Okay. When I plug that in to the left side, excuse me, I have cosine of 60 degrees is 1/2, cosine of 45 is square root of 2 over 2, and then sine of 60 degrees is square root of 3 over 2, and sine of 45 degrees is square root of 2 over 2. Now, because we have so many square roots, it's going to get a little bit complicated. You need to be very careful when you're adding and subtracting square roots. I know I'll show you two scenarios down here, and let's make sure we're doing everything correctly. All right, so when we're multiplying, it's 1 times the square root of 2, and it's just 2. 2 times 2 is 4, and then square root of 3 times the square root of 2. Go ahead and multiply the numbers that are inside because they're both square roots. You can multiply this as the square root of 6, okay? And then you have 2 times 2 again is 4. Well, you have common denominators here. Go ahead and do the subtraction. I have a lot of people that want to do the square root of 2 minus 6. And if you do that, if you plug that into your calculator, you're going to get an error message because you'll end up with like the square root of -4, which is an imaginary number. It doesn't work, okay? This is the exact answer. You cannot simplify it any more than that, okay? So let's check in our calculators. Go ahead and turn on your calculators. Type in, go to the calculation screen, type in cosine of 105 degrees. So we want to know what is this side of the equation equal to. And that's what, -0.25 something 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 something, okay? So that's what cosine of 105 degrees is. Now let's plug in our exact answer right here into the calculator and see if we get the same thing. So set up your ratio. If you set it up correctly, you'll have it like this: the square root of 2 minus the square root of 6. Make sure that minus sign is outside of the square root symbol. You don't want it inside the square root symbol like this. This is wrong here. This is what you want to have on your calculator screen. Okay, and then divide it by 4 and you get the same answer. So right here and here, that works. If you do this, you're going to get an error. So make sure you set up your fractions correctly. Make sure you keep these separated. All right, so I think this example is in your green notes as well. Let's look at one of the problems on your worksheet. Okay, you have tangent of 105 degrees. If you plug that into the calculator, you get -3.73205. Let's plug in tangent 60 degrees and tangent 45 degrees into our equation. Okay, and again, we can look at our trig table. I don't want you using your calculators at this point. Let's use our trig table. So tangent of 60 degrees is going to be the square root of 3. Tangent of 45 degrees is 1. And then in the denominator, you have tangent square root of 60 is square root of 3 times 1, which is just, when you multiply it all out, you just get the square root of 3. And then you need to simplify this. Remember, we cannot leave the square root of 3, a square root in the denominator. So we have to multiply both the numerator and the denominator by the opposite of what we have here. We have 1 minus the square root of 3. We're going to multiply it by 1 plus the square root of 3. This is very similar to one of the problems we did in class yesterday. At least some of my classes. I know some of you guys, we didn't get to it, sorry. But this is very similar to one of the problems yesterday. Let me see. So this is what we have. Let's go ahead and FOIL this and this. When you FOIL it, you end up with, let's see, square root of 3 times 1 is square root of 3. And then, let me see, how did we get 4? Hold on, I'm slowing down. Oh, let's see. So square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3 is 3. And then 1 times the square root of 3 is the square root of 3. So we have 2 of the square roots of 3. We're going to combine those like that. And then 1 times 1 is just 1. So we have 3 plus 1 gives us the 4, and then the 2 square roots of 3, we combine it there. When we FOIL this, 1 times 1 is 1. 1 times the square root of 3 is square root of 3. Negative square root of 3 times 1 is the negative square root of 3. So those two cancel out, and then negative square root of 3 times positive square root of 3 gives you -3. So we have a 1 minus 3 gives us -2. You can go ahead and reduce that where you divide everything by 2, and 4 divided by -2 gives you -2, and then 2 divided by -2, those two cancel out. So your final answer, your exact answer would be -2 minus the square root of 3. Plug that into your calculator and you get -3.73205, which is the same answer that we have here. All right, so substitute, go ahead and pause this for a little bit so the students can work through all the math. I went through the foiling fairly quickly, give them time to show all their work and work through it. Give them about 2 minutes and then start the movie again. All right, here's another example. I'm trying to remember if I worked this out with you. Yep, I did. All right, so on this side, we just plugged in sine of 15 degrees. This is what our final answer should be. Remember, with this, the whole point is getting the exact answers and then plugging it into the calculator and seeing if the rounded answers match. Excuse me, I'm starting to lose my voice. All right, we plug everything in. I'm just going to erase everything and then walk you through it. So we have sine of 60 and 45 degrees. Plug everything into your, this is the sine and this is the difference because you're subtracting. It's the sum. Or sorry, it's the difference identity for sine. Make sure you're using the correct formula, guys. Look at your green identity chart and get the correct formula. So this is what we have. Look at your trig table, plug everything in, figure out what it is. Sine of 60 degrees is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Plug everything in, multiply everything together. We have the square root of 6 here over 4 minus square root of 2 over 4. Again, you cannot combine that under one square root symbol. Make sure you keep them separate because when you, this is our final answer right here. This is the exact answer, okay? And in college, when you have a problem like this, your teacher is going to want you to leave it like this, but you can then use your calculator to verify that you did all the math correctly. Plug that into the calculator like this. Make sure those square roots are separated, and you'll get 0.258819, which is the same answer that we got up here. Okay, if you go ahead and keep have both the 6 minus 2 under the square root symbol, you get the wrong answer. Okay, make sure you plug it in the calculator correctly. This part is wrong. This is how you want to plug it into the calculator. All right, moving on. All right, so this last part of the worksheet, I'm going to let you work through it on your own. Follow the instructions very precisely. You have your X's and Y's here. This is you need to remember what we did a couple units ago when we had our ratio. Remember that your sine function is just the y value. So the sine of r would just be 24 over 25, and the sine of s would be 4 over 5. I gave you those. Go ahead and work through this, the rest of this worksheet on your own. If there's any time in class, work through it. If you guys work together in your groups, that's fine. If you need to have the substitute rewind so you can see another part of this video, you can do that too. But I want everybody working. Keep your phones put away. Work until the end of class. And just be really good for the substitute. All right, I'm hoping to be here tomorrow. This worksheet is going to be due tomorrow. I know several of you guys are not going to be here tomorrow. You'll need to turn this in when you come into class on Monday. And if you know in advance that you're not going to be here tomorrow, get the worksheets for that we're going to be working on tomorrow. Get it from the sub. I will give her a stack. Okay. All right. I will see you guys tomorrow. Bye.